In this video, I am going to explain the derivation of the optimum commodity purchase of a consumer in case of CES utility function. Let us consider the CES utility function as a utility of x1 and x2. Let us consider two commodities only. And let us consider the CES function in simple form, that is x1 raised to the power half plus x2 raised to the power 1/2 whole power 1 over 0.5. So here the value of rho is 0.5. So we know that in this case also the utility function has a set of convex indifference curves, so there is no need to check the second order condition. So we find the optimum commodity purchase just by using the optimum rule. Marginal rate of substitution is equal to the price ratio. So in this case, the marginal rate of substitution is simply the marginal utility of the first commodity divided by the marginal utility of the second commodity. So we differentiate this with respect to x1 to find the marginal utility of the first commodity. So we use the chain rule, in fact. So we assume this to be x, so this to be n. So we first use the power rule. This is n xn minus 1, which is 1 over 0.5. X means x1 to the power 0.5 plus x2 to the power 0.5 whole power n minus 1 means 1 over 0.5 minus 1. So in chain rule, now we differentiate this x with respect to x1. So our rule here is in fact del u over del x into del x over del x1. So now we differentiate this x with respect to x1 and get this is 0.5 x1 to the power 0.5 minus 1, which is negative 0.5. Over the marginal utility of x2 will look like this. This is 1 over 0.5 x1 to the power 0.5 plus x2 to the power 0.5 whole power 1 over 0.5 minus 1 times 0.5 x2 to the power negative 0.5. So all this term cancels. This 0.5 also cancels. The thing that remains is simply marginal rate of substitution. This is x1 to the power 0.5 negative 0.5 divided by x2 to the power negative 0.5. So this can be written as x2 over x1 power 0.5. So now we assume, as in our previous examples, that the price of the first commodity is 10, the price of second commodity is 20, and the consumer's total wealth is 1,000. So now equating marginal rate of substitution to the price ratio, we get x2 over x1 to the power 0.5 is p1 over p2. p1 over p2. So this gives us x2 over x1 to the power 0.5 equals p1 over p2 is 10 over 20. So this is x2 over x1, so we square both sides, and this is 1 over 4, that gives us x1 equals 4x2. Now using this relation in the budget constraint, the budget constraint is p1 x1 plus p2 x2 is total wealth. So this is 10 x1 plus 20 x2 is 1000. So this is 10 times 4 x2 plus 20 x2 is 1000. So this gives us x2 is 40, 60, 1000 divided by 60, which is 50 over 3. And the value of x1 is 4 times x2, which is 200 over 3. So the optimal commodity purchase of x1 and x2 is simply x1 star, x2 star is 200 over 3, 50 over 3. So this is the utility maximizing bundle that the consumer wants to purchase. So we can have a look of the consumer's equilibrium graphically too. For this, let us plot the budget constraint and the utility function in the graph. So this is the budget constraint, this red line, and this is the utility function, CES utility function. So this utility function, the value of utility has been calculated by just putting the value of x1, 200 over 3, and the value of x2 at 50 over. So this is the consumer's equilibrium point. So this is the equilibrium point, which is 65. Sorry. So the equilibrium point of the consumer is simply 200 over 3, which will lie some over here, and the value of x2 is 50 over 3, which is 16 point something, which lie over here. So thank you for watching this video, and please subscribe my channel for watching more videos in the future.